This talk presents results from some research on the farm-level economics of conservation agriculture for resource-poor farmers, focusing on sub-Saharan Africa and South Asia. So, of course, there have been many concerns raised about food security, farm profitability and land degradation in agriculture around the world. And as a consequence, various practices have been developed and promoted to farmers. In developing countries, a lot of emphasis has been placed on a particular package of practices under the banner of conservation agriculture. And as usually applied, that banner includes three practices: zero tillage, retention of crop residues for soil cover, sometimes referred to as mulching, and rotation of cereals with legume crops. Around the world, there's been quite a large area of uptake of this package, or a good approximation of that package. Someone's estimated that around 9% of the world's cropland is cropped using something like conservation agriculture. But predominantly that area is on large commercial farms in developed countries: the US, Australia, Canada, and parts of South America. In Africa and South Asia, there have been extensive efforts to promote conservation agriculture and strong support from advocates in the international development community, using all of the tools in the agricultural extension toolbox, such as on-farm trials, demonstration plots, farmer meetings. But the results of that promotion have been disappointing. There are a few local success stories, but mostly the level of uptake has been relatively disappointing. And I'll talk about some of the reasons for that later on. But for now, I'll just talk a bit about the debate that emerged as a result of this disappointing level of uptake. So after a few years of promotion, some critical voices started to emerge, saying that there was too much emphasis, too single-minded emphasis on conservation agriculture, and that it was being promoted in a relatively unthoughtful way, too broadly, without sort of considering the areas to which it might be appropriate. So an example is this paper by Ken Giller and some colleagues, who were really trying to, although these people had done a lot of research on conservation agriculture and were concerned about the sorts of issues that the advocates of conservation agriculture were concerned about, they were not so convinced that conservation agriculture was the panacea that some people seemed to think that it was or is. Hence they termed their paper subtitle "The Heretic's View." This generated quite a strong debate online. I came across a website where there was about 50 pages of comments back and forth between critics of that paper and authors of the paper. Critics of the paper were saying things like, the damage that this article is going to make is great. Critique was easy, but proposing something better has failed. And I believe that it's unprofessional and unethical to be saying things that would tend to encourage continuation of traditional methods. In response to those sorts of comments from their critics, Giller and his co-authors were saying things like, well, we don't write off conservation agriculture totally. We simply point out that it's not the panacea that it's claimed by many, and that the conservation agriculture advocates seem to think that we simply don't understand and are wedded to ploughing, and that they're not. So it was quite an intense debate, quite an emotional, passionate debate at times. And so seeking some common ground, the CGIAR Independent Science and Partnership Council organised a meeting, which was held at the University of Nebraska in Lincoln in October 2012. There were about 50 people from all sides of the debate involved in this meeting. And there they are. And I guess one of the people at this meeting, at least one, was not involved in the debate. That was me. I was new to this area at the time when I was invited to attend this meeting. And I was specifically invited to provide a review of the farm level economics of conservation agriculture and asked to address questions like, can farm level economics help to explain the poor adoption of conservation agriculture in Africa and South Asia? What do the existing economics studies say? Are they any good? Are those studies of high quality? And if not, what's needed for a good analysis of conservation agriculture, a good economic analysis, that is? So I think that these were good questions to ask, and for these reasons, well, for this particular reason, I think the farm level economics of any particular practice can help to provide insights into trends and tendencies of farmer behaviour. It will indicate whether it's likely to be widely adopted, where it might be and is unlikely to be adopted. Even though we all know that farmers don't literally maximise profit, profit is still a motivating factor that influences many and probably most farmers, and so this sort of analysis can be very helpful. It would also provide insights into which groups of farmers are likely to benefit from conservation agriculture and which aren't. Now, when I refer to farm level economic analysis, I need to emphasise that I'm not talking about a very narrow, simplistic analysis. I'm talking about something that is broader than simply input costs and the crop revenues. In my view, a good analysis of this type needs to encompass, at least in some way, some of the whole farm management context, some of the interactions between the enterprises, the constraints on resources, and in a developing country, resource-poor context, that's a very important factor. So we need to worry about whether the farmers have labour and capital available. It may need to account for risk and uncertainty. Farmers in these environments are known to be highly averse to risk and uncertainty and can ill afford to have downside risk occur. It's the difference. Success and failure is the difference between being hungry and not being hungry, so it really matters. Dynamic effects, particularly with something like conservation agriculture. There are dynamic effects from year to year and over the course of a decade or more. And then time preferences. We need to account for things like interest rates, interest payments, and the urgency that the farmer may feel to feed the farm family. So with that in mind, with a colleague, I went and reviewed, with a colleague Rick Llewellyn from the CSIRO, I went and reviewed the existing literature on the economics of conservation agriculture at the farm level, and we concluded that that literature is actually not very extensive. There are a number of studies, and we've written up a review of the studies that we were able to find, and that's under review in a special issue of the journal Agriculture, Ecosystems and Environment. So hopefully that review paper might come out later in 2013. It's March as I speak. Given that it wasn't very extensive, I'm not going to make all that many comments about it. So just this slide is my summary of the literature. And I'm breaking it down by the three different components of conservation agriculture and then the whole package. So first of all, zero tillage. The research that had been done there was mainly positive. The economics was mainly positive, mainly due to savings in inputs in certain locations. There was some research, but not very much, about the economics of stubble retention. The economics there mainly related to the value of of crop residues as a livestock feed. We didn't find anything that focused specifically on stubble retention alone, the economics of that. There were more studies on legume rotations, and the evidence there was mixed, but mainly positive. It mainly said that legume rotations were economically attractive at the farm level. And then there was a small number of economic studies that looked at the whole conservation agriculture package. And again, the results there were mainly economically favourable. So based on that modest set of studies, you could easily get the impression that adoption should be high. But we know from research that's been done on that adoption that it's actually not very high in many areas. So why is that? Well, why is that difference, that apparent contradiction? So one possible reason is that most of these studies are quite simple, that most of them are poorly documented, but they do appear to be missing some of the key factors that I identified earlier as being important to conduct a high-quality farm-level economic study of a farming practice. So that would be one hypothesis that I would have for this disparity, this explanation for the contradiction. Number one explanation was that the economic analysis was too simplistic or partial to be realistic. A second potential explanation is that the assumptions used in the analysis were over-optimistic, and I think that probably applies to some of the studies. A third possible explanation is that the studies may have assumed that inputs of capital and labour are available to farmers for additional, where needed for these new practices, but there are at least some situations where they're not, and I think that applies to some of the studies. A fourth hypothesis would be that the studies have ignored risk and uncertainty, and I think that they pretty much all have. There might be one from memory that included risk, but certainly the great majority had not included that. A fifth hypothesis would be that the practices are economically attractive once they're adopted, but they're not adopted for social or cultural reasons, and I'll talk about an example of that later on. And the final possible explanation would be that there are learning or transition costs that are important to farmers but have not been factored into the economic analysis. And that's certainly true that was not factored in to the analysis that I looked at, the analyses that I looked at. Okay, so because the existing evidence and research was so limited, we decided to create a new model. And what I'm going to do now is talk about the model that we developed and build it up by going through the different elements of the package of conservation agriculture, talking about those elements and talking about factors that would need to be included in an economic analysis to do a reasonable job of capturing the pros and cons of these different elements and of the practice, the package as a whole. So first, I'll talk about tillage. So traditionally, farmers use tillage to control weeds and prepare the seedbed for seeding. And this, as we saw earlier on, has led to problems with soil erosion in many areas. So that's one factor. You can see here an example of a couple of donkeys pulling a tillage implement, turning the soil over fully, loosening it up and making it more susceptible to erosion. Could be wind erosion or water erosion. And here's an example of a zero tillage implement, a jab planter that allows you to plant seeds with very minimal disturbance of the soil. So that's a technology that has been promoted in some areas. Okay, so that's one example of zero tillage, which has the advantage of reducing erosion. From a farmer perspective, a nice advantage of that is that it can save on labour and inputs due to skipping out on some of the tillage activities. So that's an advantage that would need to be represented in an economic model. It may have yield effects, zero tillage may have yield effects in some cases, although in most cases the effect of zero tillage on its own, without stubble or crop residue retention, seems to be quite small. Okay, so the main benefit we've identified is the saving on inputs, but there are a couple of counters to that, some caveats, some things, some negative factors that would also need to be factored in. The first is, if you don't till, how will you kill the weeds? A couple of options there. One is herbicides, another is labour for hand weeding. But these take extra money and or extra labour, and those costs may outweigh the savings that we've identified earlier. So we need to factor those costs in. A next factor is that some farmers may simply lack those additional resources. So if they had them, they would cost more, but they just don't have them at all. They're not available. They're too resource poor. And then a third factor here is that in some regions, the farmers may have the resources to purchase herbicides, but herbicides are simply not available. The markets just don't exist. So making that particular technology unavailable. And then another factor is that we've talked about the practice having a benefit from reduced erosion, but the benefits of reduced erosion are partly captured as public benefits and may not be captured by the farmer. There's presumably some benefits for the farmer, but a lot of the concern about erosion is not about its negative impacts on farms, it's about its negative impacts broader afield, in waterways or dams and so on, and those may not be, perhaps are unlikely to be a strong consideration in the decisions of individual farmers. Okay, the next component is crop residues. So in conservation agriculture, the idea is to leave crop residues on the surface to further reduce erosion and to serve as a mulch to retain moisture. And so the mulch can generate benefits from increasing moisture content of soils in the short term, and in the longer term it can add organic matter to the soil, which is an additional benefit. So there's an example of mulching in practice following, I think that's a corn crop. Now here's some examples of field trials on the yield effects of the combination of zero tillage and mulching. This is a figure taken from the Ken Giller et al. Paper that I mentioned before. And you can see from this graph that at least for these 5 trials, this is only 5 trials, there are many more trials than this around Africa and South Asia, but this is sort of illustrative of some of the typical results. First typical result is that it's actually quite variable. The yield effects are quite wide, can be positive or negative in any particular year. And if they are positive, they're more likely to be positive in the longer term. So it may take 10 years or more for the benefits to clearly kick in. It's not very clear from this set of data, but in the short term, it's sometimes found that there's a small negative impact before it starts to increase. So that's the first potential negative, that yields may get a bit worse before they get better. So that's a negative that would need to be factored in, both the short-term fall and the long-term gain. The second issue is that the yield benefits take a while to kick in, and typically 10 years or more before the yield benefits arrive. And so this is a particular concern, given that the farmers in the areas that we're interested in here have high discount rates and short time frames. So benefits 10 years in the future are unlikely to be of a great consequence to them, and for some of them they'll be of no consequence at all. Okay, so this is the pattern that we've assumed in the economic model. A small decline in crop yields for the first 5 years, and then a more rapid increase up to about year 10, and then we'd continue on from then with a higher yield than we would have had. Okay, so I mentioned that the benefits take a while to kick in. A second negative is that the farm residues have an opportunity cost, and I mentioned that briefly in the economic review that I talked about before. So they have a value for livestock feed, and if you mulch it, then you can't use that. If you want to get the benefits of mulching, then you can't have the benefits of livestock feed, or at least not all of them. You might allocate a portion to both, but at least whatever you do use for mulching will be a negative in terms of a loss of livestock feed. And this can be a significant share of the value of the crop, the value of the crop residues for livestock feed. So there's a photo of the crop residues having been removed from the field and stored for subsequent livestock feeding. And then the third sort of negative factor is that in some areas the local practice is to allow any animal in the village to graze the crop residues. And the farmers have no fences, and they have in fact no rights to exclude grazing livestock anyway. So if they tried to put up fences, they could face a significant backlash within their communities. So as long as this cultural practice is in place, full conservation agriculture is simply impossible. So there's an example of livestock grazing the crop residues. And you can see there's no fencing to keep. This is not necessarily just the own farmer's cattle, it could be the neighbour's cattle. The third component is the legume rotation. So the advantages of this are that it fixes nitrogen, it may provide a disease break in rotation, it provides diversification for risk reduction, and the residues from legume crops may be better quality because they contain more protein than a cereal crop would do. But the negative this time is that they may still reduce profit. It's a numbers game. It depends on the yield, the sale price, the input costs, and the subsequent effects, the rotation effects on subsequent cereals, before you could say whether or not it was a benefit. You'd have to stack it up. So you need to factor all of those factors into your economic analysis. Right, so to do that, we conducted a case study in collaboration with Mark Corbeils, who's been involved in a lot of research on conservation agriculture in Southern Africa. With his guidance, the case study that we chose was in the Mbere district, which is part of the Mid-Zambezi Valley in northern Zimbabwe. And the farming system that we looked at was a maize pigeon pea rotation, and we also allowed for livestock in this farm and also on other farms in the village. And in some of the results that I'll show you, but not all of them, we'll assume that the open access problem can be overcome. The farmer can exclude other people's cattle from grazing the crop residues that he's produced. But in order to do that, the farmer has to bear the costs of putting up fencing, which we'll have to account for. Okay, so we've allowed for 4 different farm types. So Mark identified 4 different scales of farms that were typical in this farming district, and we have data that varies for each of these farm types. So they vary in terms of area, in terms of the labour availability, and in their approach for weeding. So the smallest farm that we've used in the analysis is 1.5 hectares. It relies on manual seeding, and it has no extra labour or cash available for any higher weeds that might occur as a result of zero tillage. Then there's a slightly larger farm, 2 hectares, also relies on manual seeding, but it does have some extra labour available for weeding. Then the next size is 4 hectares. This time the farm is assumed to rely on animal traction, and it also has extra labour available it can afford costs of extra labour for weeding. And then the largest farm is 6 hectares. It also has animal traction for seeding, and it's able to afford to buy a new seeder for minimum tillage if it does adopt minimum tillage, zero tillage. And it is also able to purchase extra herbicides, We assume that they have the money to, and that those herbicides are available in the local markets. Okay, now there's a pattern that comes out that you'll see when I show the assumptions briefly, that the yields, costs, and impacts of conservation agriculture are all higher on the larger farms. So that was judged by Mark to be the realistic pattern, based on data from surveys, experiments, and his judgments from being involved in this research and observing farmer practices and results in this district. Okay, now I'm not going to spend a long time showing the results. You can email me and ask for a copy of the draft paper, or you can wait for it to appear in the journal. But I'll just quickly run through the range of assumptions that we had to make. We had to make assumptions about crop prices, costs of fencing, effects of mulching on labour and on input costs, effects of zero-till and mulching on yields, on discount rates, the amount of crop residue that's produced, its value as a livestock feed if it's used for livestock feed, the farm area, yields, production costs, the different types of inputs, and in this case you can see the 4 columns of numbers are for the 4 different farm types. So most of the numbers are different depending on the farm type. Then there's various effects of conservation agriculture on yields and costs, machinery assumptions, machinery maintenance, more about the effects of mulching on yields. So there's quite a large amount of data and a large number of parameters that need to be set. Even though it's a relatively simple model, there's still quite a lot to it, and there's a lot going on. There are a lot of different numbers that have to be brought together in a logical way. Okay, so that's all I'm going to show you of the inputs. As I say, you can ask me for more information. I'll give you a website address at the end that you can follow up and find me if you wish to. Okay, so first set of results. So these are net present values. So this is the upfront total value, if you like, allowing for discounting over future periods. There are 2 versions of that. There's a 3-year time frame and a 10-year time frame. So I've got 2 different time frames to account for 2 different types of farmers. One who needs to deliver benefits in quite a short time frame, and another who is not in such a rush and can afford to wait for 10 years for the benefits to arrive. And you can see that there are 4 different farm types down the left-hand side. Each row is a different farm type. And under the 2 time frames, there are 2 different types of farming systems. So there's a legume rotation, and that's compared to a continuous cereal rotation. And so you should be comparing those 2 columns either for 3 years or 10 years. So the numbers are net present values. They're in US dollars. And the bottom line is that in all the scenarios that we've looked at here, continuous cereal cropping is more profitable than the legume rotation. So that's for the base case assumptions. The legume rotation is worse on all 4 farm types. Now, of course, that depends on the assumptions that we've made, and it's quite possible that there are other locations where the legume crops are more profitable due to being higher yielding, or there may be years or periods when the legume grain can be sold at a higher price, or it may be that at some time in the future a more high yielding legume crop is developed, so that legume rotation will perform better. So to investigate that, we looked at a comparison. This is for 10 years only, not for 3 years. We're assuming open access. We're not assuming that there's fencing here. And we're comparing the no legume rotation on the left with the base case legume rotation, which I've already shown you in the second column, and then two more columns, one for a 30% increase in legume yields or prices, and one for a 50% increase in legume yields or prices. And you can see that on the larger farms, the green shading indicates farms on which the new conservation agriculture practice is at least as good as the traditional conventional no legume rotation. So the legume rotation could be better than not if the legume yield or price is significantly increased. It's not much better, but it is better. Okay, the second set of results relates to zero tillage. And here, for the base case set of assumptions, you can see that only on the largest farm, this is zero tillage without mulching. So it's just, the benefits here are purely due to cost savings where they're available. Now you might recall that from what I've already said, that cost savings are only really available on certain farms. And in fact they're available on the largest farm because this farm is able to reduce its costs associated with tillage, and in the process, when the additional weeds occur, kill them with herbicides, not with additional labour. So that's why Farm 4 is the farm on which zero-till is at least as good, if not better, than conventional agriculture for both time frames. So it's shaded green in both cases for the farm type 4. On the smaller farms, that doesn't work because on farm types 2 and 3, the farmer has to invest in additional labour costs, which offset the cost savings from reduced tillage. And on the smallest farm, the farmer doesn't spend additional money on either herbicides or labour, and so has to put up with additional weeds, which reduces yields. So the reduction in yields is a big cost, which outweighs any benefits from reduced tillage. Okay. The next set of results shows sort of the pattern as you go from conventional agriculture through various steps to conservation agriculture. So the left-hand column of results is conventional agriculture for the four farm types, and the right-hand column is conservation agriculture for the same 4 farm types, and in between we've got 3 intermediate steps: legume rotation only, zero tillage only, and zero tillage plus mulching. Now the results here are different to the ones I've shown you up until now, in that the ones I've shown you to now assumed that there was no fencing, so neighbours' cattle were able to feed on crop residues. This time I've made it possible for stock to be excluded if that makes economic sense. So if it has an asterisk, that means that the stock are not excluded, that the benefits of excluding stock to allow a farmer to keep their own crop residues are not sufficient to outweigh the costs of the fencing. You can see that in one case, in the second column of numbered results, there's a case where the cost of the fencing is worthwhile, but in the other first three columns, in the other cases, there are asterisks in each case. So open access is actually preferred. But in the 2 right columns, where there is mulching included, you have to include fencing. Okay, so the results show that for the 3 smaller farms, for the base case assumptions, the optimal strategy is conventional agriculture, while for the largest farm, the optimal strategy is zero tillage. Now, if I was to assume that the fencing was already in place and treated as a sunk cost, so that it doesn't influence the farmer's decision of whether or not to undertake conservation agriculture, then the optimal strategy in results that are not shown here would become zero tillage plus mulching on farm type 4, only on farm type 4. So it is possible to get to get closer to a full conservation agriculture package. And then if you had fencing in place and you had higher legume yields or prices, then you could get the conservation agriculture option to be the best option on farm type 4. So it is possible for it to be the best strategy. But it's also quite possible for it not to be the best strategy. You can already see from these results that conservation agriculture probably in many areas needs to be targeted reasonably carefully and thoughtfully, selectively, to those types of farms who can benefit substantially from it. And it's very likely that some types of farmers would not benefit from its adoption. That's just an unfortunate and difficult reality that we need to grapple with when thinking about how to tackle the sorts of problems that conservation agriculture is intended to tackle. Conservation agriculture, as currently designed, is clearly not sufficient to be suitable in all cases. Certainly at least for this case study, and then it's a moot point how broadly one could extrapolate from this case study to other cases. I guess all this is doing is illustrating that for this case study, there are certainly examples of farmers who would not benefit. So the final set of results I want to show is for risk and uncertainty. Okay, now this is for a scenario where initially, before I bring in risk and uncertainty, conservation agriculture and conventional agriculture in the two left columns are equivalently profitable on the largest farm. And they're reasonably close on farms 2 and 3. So the left-hand two sets of results are for a model that doesn't represent the riskiness or the uncertainty associated with conservation agriculture. The middle two columns, with labelled risk only at the top, show the results when I represent variation in crop yield and yields of both crops and prices of both crops, and you can see that, and then what I've done is represent a standard subjective expected utility model, and assume that the farmers have high levels, very high levels of risk aversion, which you would think would be typical for these sorts of farmers. I've assumed a risk aversion parameter of 4 for relative risk aversion. If you know about modelling risk aversion, you'll know what that means. It means that these farmers are very risk averse. And so that a risk premium has been deducted from the numbers in the first two columns to produce the results in the second two columns. All of the numbers in the second two sets of columns are lower, but for conventional agriculture, they've fallen by more than for conservation agriculture. So the conservation agriculture has a risk benefit. And for two of the farmers, that has meant that conservation agriculture now looks better, so on farm 4, it now looks clearly better than conventional. Previously it just looked equivalent. And on farm type 2, it now looks as good as conventional. Previously it looked a bit worse. So risk can help to increase the consideration of risk, can help conservation agriculture to look more attractive. A bit more attractive. Not dramatically, but a bit more. Unfortunately, when you then bring in uncertainty, so uncertainty basically means lack of knowledge. By risk I mean sort of a known variability, a more or less predictable range of yields and prices would occur. But uncertainty, what I'm representing there is the fact that prior to farmers adopting and getting experience with conservation agriculture, they are bound to be uncertain about how it will perform. And so what I've represented here is uncertainty about the benefits of conservation agriculture relative to conventional agriculture. The uncertainty is only about the benefits, the difference between conservation and conventional. And so that is a negative, clearly a negative for conservation agriculture. And when you bring that in, it further reduces the results. There's a further uncertainty premium deducted off the conservation agriculture results, which unfortunately pushes them back down so that they are now all lower again than the results for conventional agriculture. Okay, now these results are very specific to this case study and to the assumptions I made about the level of risk aversion and the level of variation and so on. So, these are illustrative results. They show that when the benefits and costs are close, as they were in the first two columns, risk and uncertainty can make a difference to the ranking of the options. So risk will tend to favour conservation agriculture, and uncertainty will tend to disfavour conservation agriculture, potentially by more, depending on what you assume, by more in this case study. But overall, at least for this case study, we found that the effects of risk and uncertainty were not really dramatic. They were significant. They could be significant to a farmer. But if conservation agriculture was already significantly inferior to conventional agriculture, as it was for farm type 1, for example, in the no risk or uncertainty case. So for farm type 1, conventional agriculture had a net present value of $1,200, conservation agriculture had $370, so clearly worse for conservation agriculture. Then it doesn't really matter whether you bring in risk and uncertainty or not. The difference is too big to make up, even if you only factor in risk. So representing risk and uncertainty is not always going to make a difference. It may make a difference if the results are reasonably close before you bring them in. Okay, so the conclusions from all this. First, it's a numbers game. There are lots of different numbers that need to be considered, and the question is, how do they stack up? You can't just assume that any particular farming practice is better than another without doing a fairly careful stacking up of the numbers. From the case study that we've looked at, it appears that conservation agriculture performs best on well-resourced farms with longer time horizons. I guess that's not surprising when you think of the cases around the world where it has been adopted and hasn't been adopted, that those results sort of pass the common sense test. And the other observation I'd make, and it's specific to this case study, but it might be more widely applicable, is that conservation agriculture may not be compelling even then. I showed a number of results where conservation agriculture was superior to traditional agriculture, but it wasn't dramatically superior. It was a bit better, but it wasn't 20% better, I don't think, in any of the cases. It was somewhat less than that. So it's important to remember that I haven't factored in things like the learning costs and the transition costs, other than the costs of purchasing new machinery. So, the idea that you need a strong driver to get farmers to pick up a new option, I think so, is correct, and I guess we didn't really find that in this study. Then the next conclusion is that selective adoption might be best. Now, some people have been surprised and perhaps frustrated that the farmers have adopted a subset of conservation agriculture rather than the full package. But to me, as someone who's done research on adoption of new practices by farmers, that's not surprising at all. It's actually very common. That is the normal way that farmers respond to new practices. They are selective. They pick and choose the bits that they think will work best for them. And you can see from the results of the case study that at least in some situations, that's likely to be quite sensible. We found that, depending on the numbers, it may be optimal to adopt not conservation agriculture at all, or just zero tillage, or just zero tillage and mulching, or the full package. And then the final observation on this slide is that uncertainty may be an impediment to adoption. It might swing it for some farmers. So it might be worthwhile trying to think of strategies to help farmers reduce their uncertainty. And of course, that is a lot of what agricultural extension tries to do. Okay, now what can we conclude from this case study? Well, I've tried to be cautious in saying that we can't conclude too much. It's not too generalisable. The results indicate trends and principles and possibilities, but I think it does reinforce that conservation agriculture isn't necessarily as strongly positive for farmers as I guess we would like it to be. It also reinforces suspicions about the quality of the analysis in some of the previous literature on the economics of conservation agriculture. The fact that so many of those studies found positive economic studies, to me, when having done this study, it makes me worried about how comprehensive, how relevant those studies are. So there are some implications that follow from these conclusions. One that I think is really important, but is unfortunately rarely done in practice, is that we should be doing this type of analysis before we start doing widespread promotion of a new complex farming practice. This sort of analysis should be done in conjunction with field research and targeted participatory research in areas where we think it might be successful before we set out to promote practices widely. And then once we understand the areas where a new practice like this is likely to be attractive, we should undertake targeted promotion to suitable farm types in suitable areas. Now in that vein, I suspect, without having done a case study there yet, that South Asia might have better prospects. There would be reasons to suspect that in terms of larger farm types, better mechanisation for a larger number of farmers in some regions. So there might be reasons to be more optimistic there. Sort of follow on from that is that a targeted approach would be much more efficient in cases where targeting is needed, both for researchers and for the resource-poor farmers. We really don't want to waste the resources of resource-poor farmers. So it is worth being careful about where we engage them over new practices before we try to raise their enthusiasm and hopes too high. And then the final implication is that given that conservation agriculture is not a panacea, we do need more research to develop better types of conservation agriculture or better alternatives to conservation agriculture for those types of farmers and for those regions where better options are needed. Okay, thanks for listening. If you'd like to follow up and see my other research, you can find me, David Pannell, on this website. There's an email address there that you can follow up, or there's a link to my personal website which has got various papers available, including a working paper version of this paper. No, actually that's not true. I better put one up. Okay, thanks for listening.